Welcome to a new video. Today we are going to talk about classification metrics. Evaluating a machine learning model isn't just about accuracy. It's crucial to consider other metrics to understand how well your model is performing. These metrics include precision, recall, F1 score, and many more. We will explore each of these metrics, write some code to compute them, and then visualize the results. Let's get started. Before jumping into the metrics, let's quickly discuss what classification problems are. Essentially, a classification problem is where you have to predict a discrete label or category. Think spam versus non-spam emails. The output is a category, such as spam or not spam, as opposed to a continuous value. Let's just see a classification problem example here. The code here generates a simple two-dimensional classification problem using scikit-learn. You will see points scattered on a plane covered according to their classes. As we go through this video, we will be referring back to this sort of example to explore how metrics work. We need to understand four key terms for calculating these metrics. The first one is true positive. True positives are the cases where both the actual class and the predicted class of the data point are positive. By predicted class, I'm meaning that the predictions which we made with our models. The second one is true negatives. These are the cases where both the actual class and the predicted class of the data point are negative. Now we are going to talk about false positive here. False positives are the cases where the actual class is negative but the predicted class is positive, also known as type 1 error. And the last one is false negative. False negatives are the cases where the actual class is positive but the predicted class is negative, also known as type 2 error. Great, let's start. Let's say from sklearn.matrix import confusion matrix. We are going to talk about it, and let's create two lists, which is going to one of them is going to represent the true values of y, and one of them is going to represent the predictions we made with our model. Here is our lists. You can see that there's matching ones, non-matching ones, like in every real world scenario. You can see that sometimes it's 0 here and 1 here. Here are our lists for this lecture. So here we are going to generate the confusion matrix like CM confusion matrix. We will say y true and y predictions. We can also print this confusion matrix. And now what we are going to do is we are going to extract true positive, true negative, false positive, and false negative from here. We will say true negative, false positive, false negative, and true positive, and we will use confusion matrix.ravel here. And now we can see the true negative like this and false positive like this, false negative like this, and true positive like this. Here are our values. In this example, I have used scikit-learn's confusion matrix to calculate these four terms: true positive, true negative, false positive, and false negative. These are the building blocks for all other metrics we are about to discuss. The most straightforward metric is accuracy. It is the ratio of correctly predicted instances to the total number of instances. We are going to calculate the accuracy by, let's say accuracy, we will say true positive plus true negative, and we are going to divide this by true positive, true negative, false positive, and false negative. And let's print this like, let's use f-string accuracy, and let's take accuracy here. So our accuracy is 0.75, which we can also refer as 75%. Here, the formula for the accuracy is implemented in Python. We use the previously calculated values of true positive, true negative, etc. to compute accuracy. Now we will talk about precision. Precision is the ratio of true positives to all the predicted positives. It tells us how many of the items identified as positive are actually positive. Let's say precision, and we will say true positive divided by true positive plus false positive. It's our precision. Print precision, and we will say precision like this. In this code, we are calculating precision using the values of true positive and false positive. High precision indicates a low rate of false positive errors. Now we will talk about recall. Recall, also known as sensitivity, is the ratio of true positives to all the actual positives. It measures the ability of the classifier to identify all the positive samples. We will say recall is going to be equal to the true positive divided by true positive plus false negative. And let's say print recall, and let's take recall here. Here we calculate the recall using the values of true positive and false negative. High recall indicates a low rate of false negative errors. Now we will talk about F1 score. The F1 score is the harmonic mean of precision and recall and provides a balance between them. It is defined like we will say F1 score, and then we will say is 2 multiplied by precision multiplied by recall, and we will divide this by precision plus recall. This is our F1 score. F1 score is, let's say, F1 score. We calculate the F1 score using the previously calculated values of precision and recall. The F1 score is particularly useful when you have an uneven class distribution. Now we will talk about receiver operating characteristic, like we can refer it as ROC curve. The receiver operating characteristic curve is a graphical representation of a classifier's performance. The curve is created by plotting the true positive rate against the false positive rate at various thresholds. The area under the ROC curve measures the classifier's ability to distinguish between classes. So let's do that. We will firstly start by importing from sklearn matrix curve, and we need this one here, and we will calculate the ROC curve here. False positive rate, true positive rate, thresholds is going to be equal to the ROC curve. We will pass y true and y predictions. And let's say false positive rate and true positive rate. Here it is. Now we are going to plot this. We will say plt.figure. I'm not sure we imported matplotlib, so we can just import the matplotlib. Let's import matplotlib.pyplot as plt once again, if we did also. Let's use plt.plot, and we will take the false positive rate, true positive rate. Let's set color as dark orange and label as ROC curve, and we will do area is going to be equal to the ROC AUC. Then set xlim here, like let's give here a list like 0.0, 1.0, and then we are going to do the same for the ylim. We will do 0.0. Let's use 1.05 here now. Then I'm going to say xlabel is going to be also, let me scroll down a little bit. We will say false positive rate. It's going to be a good thing at the end. Ylabel true positive rate. Then we will say plt title receiver operating characteristic, and we will set the legend as lower right. Here it is. We set its location, and for the last step we are going to use plt.show here. Here we use the ROC curve and AUC methods from scikit-learn to calculate and plot the ROC curve. The closer the curve follows the left and top borders of the ROC space, the more accurate the test. Now we will talk about Matthews correlation coefficient. The Matthews correlation coefficient is a balanced measure for binary classification that considers all four values from the confusion matrix. The range of Matthews correlation coefficient is from -1 to 1, where 1 indicates a perfect prediction, 0 presents a random prediction, and -1 indicates an inverse prediction. For calculating it, we are going to start by importing math here, and then we are going to say, we will open two parentheses like this. We will multiply true positive with true negative. Then we are going to say minus here, and then we will do false positive multiplied by false negative. Then we will use square root here, and then we are going to say true positive, false positive, and we are going to multiply this with true positive plus false negative. Then we are going to multiply this with true negative plus false positive, and then for the last step we will say true negative plus false negative. Here it is. You can think this as we are taking the all combinations, Matthews correlation coefficient, and we will say MCC here. In this code we calculate the MCC using all four values from the confusion matrix. After this symbol here, you can see that we took all the combinations, and here it is. A high Matthews correlation coefficient indicates a better classification. Let's talk about logistic logs. Logistic logs measures the performance of a classification model where the prediction input is a probability value between 0 and 1. Lower logistic logs values signify better model performance. For calculating it, we will say from sklearn.matrix import logistic loss here, and then we will do logistic loss. We will say logistic loss by true and ypred, and then we will say print. We will use f string again, logistic loss, and we will just take this. Lower values of logistic loss indicate better model performance. Now for the final, we will talk about balanced accuracy. Balanced accuracy calculates the arithmetic mean of sensitivity and specificity, and it's particularly useful when dealing with imbalanced datasets. We can say balanced accuracy here, and it's going to be 0.5 multiplied by true positive divided by sum of true positive and false negative. Then we will do true negative divided by true negative plus false positive. Also we need parentheses in here for it to give us the correct result, and we need to 1 at the end, and now it's perfect. Let's print this. Balanced accuracy, and we will say here balanced accuracy. In this code we are computing the balanced accuracy using the values of true positive, true negative, false positive, and false negative. This metric is useful when the classes are imbalanced and one class's performance is more important than the other. That was all. Thank you for watching my video. I'm creating content about data science and programming. You can follow my channel for more. Have a great day.